In the name of God, hello dear students of grade 7. Welcome back to Thinkable Physics YouTube channel. My name is Masoud. I'm a science teacher. I want to be with you with the new subject, which is the properties of gases. But before I start, I want to jog your memory about the previous lesson. We talked about the properties of solid and properties of liquid. Right now, our concentration is on gases, right? The first, actually, the first thing that I want to read it for you, actually the definition of gas. Like previous lectures, I want to underline the important information, and I want you to grab your science book and put it in front of yourself and highlight important information with me, right? Let's get started. Gases change in both shape and volume. Change in shape and change in volume. I'm going to number these properties for you. Change in shape, number 1. Change in volume, number 2. I'm going to do the simple experiment for you for better understanding these properties. I want you to bring two different containers. Balloon with a bag, right? I'm going to blow them up separately, and I want you to tell me what does this experiment actually tell you. Let me blow the balloon up. So whenever you blow the balloon up, does the air take the shape of the balloon? Of course, yes. What do you say about the second one? I want to blow the bag as well. So the same air takes two forms, takes two shapes. Shape of the bag is completely different from the shape of the balloon. This is the simple experiment to prove that the shape of the gases actually changes, right? Shape of the gases changes from container to container, right? This is about the first property. What do you say about for example, another property, which is the change in volume, change in volume of the gas, right? I'm gonna tell you about an experiment. Let me draw think about two gas tanks. Two gas tanks. One is small, one the small tank, another the larger tank. Let me draw it for you. So, for example, we have a gas tank like this. This is the first gas tank. Another one is larger than this one, right? For example, another one is like this. So we have two gas tanks with different volumes. For example, the volume of the first one is just for understanding. These numbers are not real. They are just for understanding. For example, 5 or 50, for example, 50 milliliter, right? 50 milliliter. The second one, the volume of the second one is actually 100 milliliters. 100 milliliters. Whenever you fill each tank, by any gas, actually, by helium, by propane, by LPG, by anything, whenever you fill it, so the gas actually occupies the whole volume. The same gas, for example, occupies the same whenever you fill it. You fill it with, for example, with the gas. I can fill the first one with 100 milliliter. So what do I mean by this? When the volume of the gas of the first tank is 50 milliliter, but you can fill it with actually 100 milliliters. How is it possible? It's possible for gases because gases particles are very far from one another, right? because they are very far from one another. For example, think about the particles of gas. This is the first particle, this is the second particle, this is the third one. So there's a big gap between two neighboring atoms of the gases. That's why whenever you feel any tank, for example, what happens to the gases? They are compressed. So gases are compressible. You can fill this actual tank with 100 milliliter. It's possible. The volume of the second tank is 100 milliliter. I can fill it with 200 milliliter. How is it possible? Because of the actually because of this property of the gases, that the gases are compressible. You can change the volume of the gases. What do I mean by this? If I say compressible, means you can change the volume of the gases. But this property is the actually unique property for gases. Is specialized for gases. There's no actually this property. There's no this property neither in solid nor in liquids. You cannot compress liquid. That's why liquids are not compressible. And I explained it for so far. But about the gases are compressible. This is about the change in volume. Right. Let's move on to the third information. I wanna actually let's keep going. So there is more distance between particles of gases. So more distance between particles. What's the more distance? I explained for you. There's a big gap between two neighboring particles. That's why there's a more distance between the particles. The third property. This is the third one. The fourth one, the particles of a gas move quickly. They are free to move. The fourth information, excuse me. The fourth information, they are what? They are free. They have freely motion. Gases are freely actually moving. So particles are moving quickly. There's less attraction between the particles. The fifth one, less attraction between the particles of gas compared to the solid and liquid. So we have 5 properties. The fourth one, particles of gas move quickly. They move rapidly. The fifth one, there's a less attraction between the particles of gases. And this is about the properties of gases. Let me read the information of figure 6. The figure 6, there's a gas tank. The gas is actually filled with helium, and you can fill these balloons with different volumes by this tank. Let me read the information. Many balloons can be filled from one tank of helium because the particles of helium gas in a balloon are far apart. They are far apart, and that's it for the gases. But before I finish the lesson, let's get back to some questions about the gases and definition of gas. So what's the definition of gas? This is the definition of gas. It says a form of matter that does not have a definite volume or shape. It's a state of matter with different shape and different volume. State of matter with actually indefinite shape and indefinite volume. And we have a self-check. Why do gases spread throughout the container? Why do gases spread throughout the container? Because of the big gap, because of the separation between the particles. Because they are very. I want you to answer it. Actually, comment it after you watch the video. To comment your answer for me. Self-check. Why do gases spread throughout the container? And before I finish the lecture, I wanna compare I want to compare between the particles of either phase, solid, liquid, and gas. I want you to be with me to the end of the explanation. For example, we have solid, right? Solid state. Particles of solid state are very close to one another. They are particles of solid state. They are about to touch each other. There's a very small gap between two neighboring particles. Because these particles attract one another very strongly. So there's a big attraction between two neighboring particles. One attracts the other, right? First one attracts the second one. Second one attracts the third one, and etc. This is about the solid. So keep in mind that there's a small gap between two neighboring particles. Particles are about to touch each other. This is about the solid, right? What do you see about, for example, liquids? About the liquid, particles, how do particles arrange actually? How do particles? Particles are a little bit far from one another, right? They are not very far. They have a medium gap between two neighboring particles. That's why, and they attract each other. There is a force of attraction between the particles, but compared to the gas, actually there's a less attraction between two neighboring particles, right? That's why here we have in the gases, in the solid, we have vibration. The motion is called vibration, right? Because we have a restricted motion, limited motion. The type of the motion in liquid is called actually sliding past each other. Sliding. Particles are just sliding past each other. Sliding past actually one another. This is about the, for example, properties of what? Properties of liquid particles. What do you say about the properties of gases? How do particles of gas actually arrange? How to sit beside each other? There's a big gap between two neighboring particles. You see? That's why because particles are far away from one another, there's a less attraction. There's a less attraction between two neighboring particles. That's why you have to put a gas in a sealed container. You have to actually put them in a container and fasten the cap of the container. Actually, otherwise, actually, it escapes from the container, right? That's why we have freely motion, and the motion is called actually, you can say freely motion or rapid motion, very rapid motion. We have a rapid motion here, right? Let me actually, and I want you to draw a table. I want to draw a table, and I don't actually fill the table for you. I want you to draw it for me. So we have a solid, liquid, and gas, right? After the lesson, I want you to fill this actual table and send it to me after the lecture. Solid, liquid, and gas, right? We have this property. We have these states with different property. For example, shape. We have shape versus what? Shape versus volume. Shape versus volume. I give you two words, right? Definite, indefinite. So you have to fill the gap with definite or indefinite. Go to the solid. Solid. Does solid have definite shape or definite volume, or indefinite shape, indefinite volume? Go to the liquid and fill this table for me after you watch the video. That's why I want to finish the lesson here. Thank you very much for watching this video, and bye bye.